Alright then, hello guys. Today we're doing another crypto hacks challenge, and the challenge we're gonna be doing today is gonna be called XOR Properties. It says right here, in the last challenge you saw how XOR worked at the level of bits. In this one we're gonna cover the properties of XOR operations, then use them to undo a chain of operations that have encrypted a flag. Gaining an intuition for how this works will greatly help when you come attacking real crypto systems later, especially in the block cipher category. There are four main properties we should consider when we solve the challenge using XOR operators. So we get commutative, which A and B could be switched to B and A. Associate, where A and B, where A and then XOR B XOR C is equal to AB XOR C. Identity, where A XOR 0 is equal to A, and then self inverse, where A XOR A is going to equal to 0. So we got key 1, key 2 and 1, key 2 and 3, and then key 1, 3, and 2 is equal to this value. So we know key 1 is equal to that. But now we need to get key 2 and key 3. So what we could do is basically we already have key 1. So let's go nano solve dot pi. So let's just delete this from our previous challenge. So now we know that key 1 is basically equal to this, and let's use from pwn import all. This is basically a Python library that's very popular among CTFers. In this case, let's delete that. Let's copy this instead. Key 1 is equal to that value right there. So key 1 is equal to that. Now what we want to be able to do next is basically have, so we already know key 1 is equal to that value. So we could just like put it in quotes. And it says before you XOR these logs, be sure to decode from hex to byte. So that's pretty easy. So from hex to bytes, so we can just do bytes and then dot from hex, and then just wrap this around and like that, bytes, and then from hex. So now we know key 1, but we want to be able to get, I guess, key 2, key 3, and key 2. So key 2 is pretty easy because all we need to do is simply XOR key 1 right here. Because if we XOR key 1 with key 2 and key 1, basically key 1, because we have key 1, key 2, and key 1. But if we XOR key 1 again, that's basically gonna be key 2 XOR 0, and then that's basically gonna equal key 2. So that's how we get key 2. So we just put this in parentheses like this. So key 2 is basically gonna be, and which could be pretty easy, XOR then bytes from hex, and then we can just insert this value right here, key 2 and key 1, and what we'll XOR is basically key 1. And now key 3 is basically, we're gonna do the exact same thing where we're gonna use XOR, and this XOR is coming from the pwn import function, so that's where I'm able to get this. So XOR is basically gonna be bytes from hex, key 3 XOR bytes from hex. It's gonna be from right here, key 2 and key 3, but we're gonna XOR it with not key 3, with key 2, because that's gonna be the only key 2 value, which is gonna give us key 3. which is basically the same logic that we have up here, where I guess we have key 2 XOR key 3. But what we're gonna do is add a key 2, and then it's gonna be key 3 XOR key XOR 0, which is equal to key 3, which is what we're doing right here. And now we basically have all the components to XOR everything. So we could do something like this. We could do, now that we have everything, we could probably finish this up where it's key 1 and key 2, which we could grab this right here. We could do XOR or XOR bytes from hex this, because this is key 1 and key 2, and then close it out. Ooh, I didn't close this out right here. That was probably gonna generate an error. Close it out right there. Close it out when here. That's 1 and 2, and then we just need key 3. And that's basically equals to key 1, 2, and 3. So now we have key 1, 2, and 3, because this is 1 and 2, and then at the end is 3. So we have all of this right now. So we have that part, and all we need to do is just XOR that value with this right here, which is the flag key 1, 2, and 3. And if we do that, because now we have, because at the moment we have we have this currently, flag key 1, key 2, key 3. But since I have key 1, key 2, key 3 right here, so we have flag, and then we have this. And what I'm gonna add is another one of these, which is gonna make it flag XOR 0, and we know from this property flag XOR 0 is gonna equal to flag. So now if we do key if we do XOR, I think if we could just do XOR key 1, key 2, key 3, and then the last value right here, which is bytes from hex. Which is gonna be a bytes from hex, and then we just do this right here, and then I think if we just do print, we should get our flag, unless we need to, I guess, do an extra step, but I think that should be it. Now if you run Python 3 solve.py, crypto XOR is associative, and we get the flag. So I guess let's go over our logic again. So initially we have key 1, and then we need to use byte from hex to transform this, as it says right here. Before you XOR these objects, be sure to code from hex to bytes. So we got key 1, and now we need to find a way to separate to get key 2. And key 2 is basically, since we already have key 1, we just XOR it, the value that we get here, key 2 and key 1. By XORing it, we get initially key 2. And then we do the exact same step to get key 3. So at the end, when we XOR everything, we have the final key 1, key 2, key 3 all together. So when we XOR this at the end, this eliminates key 1, key 2, key 3, and we could get the flag at the end. And this is just by following these properties right here. So now if I run it and we see it, crypto is associative, and then if we check the final answer, crypto is associative. So that's the final answer. So yeah, pretty cool challenge. pretty fun also, because it kind of gets you guessing on what to do, but kind of gets you in the zone on trying to solve the challenge. But yeah, that's about it. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.